All right, guys, we're going to learn about finding the lengths of segments. So sometimes we have chords that intersect. So that is within a circle, a line that goes from one side of the circle to the other. Sometimes they kind of intersect in the circle. And we have an equation for how to find the lengths of these segments. So we have a relationship with that. We also have segments that are secants, which means that they go from inside to outside of the circle and they kind of maybe meet on the outside of the circle. We're going to find a way, there's a relationship to find the lengths of those segments as well. And there is also a way of finding the lengths of the segments when we have a secant line it crosses the circle at 2 points but keeps going outside, and a tangent line, a line that only intersects the circle at 1 point. So we have some relationships for those. We're going to start off with an example solving for a segment with two intersecting chords. So we're going to have a circle, and our circle is going to have two chords that kind of intersect in the middle, or we don't know exactly where they intersect. I am given these lengths, okay? So I know that this segment's 10, this one's 15, that's 14, and we want to solve for x. So the relationship between these intersecting chords is that AB, A times B, is going to equal C times D, where AB falls on the same line and CD falls on the same line. Okay, so if I multiply these two segments together, the two lengths together, it's going to equal the product of these two together as well. So I'm just going to go ahead and plug it in. I'm just going to say, hey, that x is A and 10 is B, whatever, or vice versa. It doesn't matter. So 10 times x is equal to 14 times 15. Okay. All right, so if I multiply 14 times 15, I get 210. And now I want to get x alone on that side to solve for it. So I'm just going to divide. Since they're being multiplied, I do the opposite. I'm going to divide by 10 to both sides, and I get x equals 21. Easy. That's our first example. All right, next example is right here we have two secants intersecting on the outside of a circle, and we're going to divide this segment into parts, just like the last one, where A and B are part of one segment and C and D are part of another. So the equation of this is we multiply A, so the part outside of the segment, times A plus B, and then multiply C, the part outside of the segment, times C plus D. And remember, we always do parentheses first when we're solving this problem. So I'm going to get an example where, let's see, we have A equals 8, okay, B equals 19, C equals 9, and we're just going to say D equals D, or we can make it X, it doesn't matter. It's just a variable. So I'm just going to go ahead and plug these things into my formula. So A is 8, so I'm going to say 8 times 8 plus 19, which is 27, is equal to C, this short segment on the outside, which is 9, times C plus D. Well, we don't know D yet, so I just have to leave that variable there, plus D, like that. Okay, and it's kind of hard to see what to do next, but remember, we can't separate anything inside the parentheses first because everything's kind of stuck together. That's what the parentheses tell us. So what I'm going to do is I'm going to distribute the 9 because I know I can do that at least to get rid of those parentheses on the outside. Oh, and also I can multiply this so I can solve for that. So 8 times 27 is 216. And I'm going to go ahead and distribute the 9. 9 times 9 is 81. Plus 9 times D, well, we don't know what D is, so it's just 9 times D, 9D. Okay, now I don't have parentheses, and this is easier to look at, and I can start solving for D. So 9 is kind of stuck to D, so I can't divide by 9 quite yet. I have to work from the outside and work in. So I'm going to subtract, since 81 is being added to 90, I'm going to subtract 81 to both sides. And then I get 9D equals 135. Now I just have 9 times d. Now I can separate these. Now I can divide by 9 to cancel out that 9. And if I do it to one side, I have to do it to the other. So 135 divided by 9 is 15. So I get d equals 15. And that's it. That's how you solve for a segment with intersecting secants outside of the circle. All right, now let's look at an example of a circle with 2 segments, one secant line. So that means a line that crosses the circle at 2 points. Okay, and one tangent line. So a line that only crosses the circle at 1 point. So it kind of is on the outside of the circle. And where they intersect on the outside at a point. Well, let's first label this. So the distance from that point to where they intersect, we're going to call that A. And the segment from the outside part of the circle of the secant, we're going to call that B. And then what's inside the circle, we're going to call C. So our formula for that is A squared is equal to B times B plus C. So let's look at an example. In our example, we're going to say A is 16. B is 8. And C, let's call it 5x minus 1. Okay. So we want to solve for x, but we also kind of want to know this distance so that we know the exact measurement of that segment. Okay, because we know all the other segments, we need to find x to find the measurement of that segment. So I'm just going to go ahead and plug everything into our formula. The part of my tangent was A, so I'm going to plug this value for A, 16, in my formula. The part of my secant outside of the circle is B, which is 8, so I'm going to plug that in for 8. That's also B, so I'm plug that in for B. And then lastly, C is 5x minus 1. I'm going to put that in parentheses because there's kind of a lot to that. So I'm going to go ahead and start solving for x so that I can find this distance right here. So 16 squared is 256. And I can kind of combine these parts. So 5x can't be combined with anything because it has no like terms here, but I can add 8 minus 1, and 8 minus 1 is 7. So I can simplify that to 8 times 5x plus 7 because it's positive 7. 8 minus 1 is positive 7. Okay, that's one way to simplify it. Now I'm going to go ahead and distribute this 8 so we can get rid of the parentheses. So I am going to get 40x plus 56 is equal to 256. Okay, now I'm going to make some room. Okay, now I can solve for x. I'm going to need to subtract 56 first. So minus 56 to both sides. I have 200 is equal to 40x. And now I just have 40 times x, so I'm going to do the opposite to get rid of 40 on that side and leave x alone. Cross that out because 40 divided by 40 is 1, so it cancels out. And 200 divided by 40 ends up being 5. So I find out that x equals 5, and I can plug that 5 back into this segment to find out what this segment is, this measurement. So 5 times 5, if I replace 5 for x, 5 times 5 is 25. 25 minus 1 is 24. So this segment winds up being 24.